Hello YouTube, this is Mike Shelley with another repair video. This time my Frigidaire fridge gave out and stopped cooling. Here's how I repaired it. Interestingly, we noticed that something was wrong because of the freezer, which only cooled down to the 30s instead of the 20s or even 10s as usual. And then we noticed that the temperature in the fridge was in the 50s, which is not good for perishable food. So I did all the usual checks. I removed the backplane and looked at the grid, which was ice-free, which is suspicious because usually there's a little bit of frost on there. So I decided this must be something more involved and pulled it out of its space to take a look in the back. The first thing I noticed was there's this open design, which is kind of weird, but apparently that's how it's supposed to be. And this tray that collects the water from the melted frost just sits on there loosely, which is also weird, but apparently by design. Now what you see here on the right is the compressor. That's a mechanical motor that compresses the coolant that has turned into a gas and made the fridge cold back into the liquid coolant. And it typically makes some noise when the fridge turns it on. You could describe it as humming or chirping. But oddly, I noticed that it was absolutely silent. While at the same time, the relay that is attached to the motor made this clicking noise as if it tried to turn on the motor but couldn't. Now what was really weird was that the compressor, although it was clearly not running, was getting really hot on the outside, 140 degrees Fahrenheit. And I had read online that this might be a symptom of a defective relay, which, unlike a compressor, which is a major task to replace, can be swapped out cheaply and easily. So I decided to go that route. First of all, you need to unplug the power because we're going to touch some live wires otherwise. Also note this big capacitor, which might still carry some load, although the wire is unplugged. So be careful. Now, first of all, we need to remove the case for the relay. And believe it or not, I tried for hours to get this off because there's some markings on the case that indicate something about some strange movements you need to do. But it's all baloney. All you need to do is put a screwdriver in there and then pry it away from the compressor. That's it. Then it'll come off. Now, with a little bit of patience, you can wiggle the case out to get access to the relay. It is a little bit involved because there's no less than 7 different cables attached to that relay. And the relay is plugged into the compressor. It touches it and basically feels whether the compressor gets too hot, and in which case the thermistor inside the relay will shut off the relay as a safety mechanism. To detach it from the compressor, insert a screwdriver like I did here and pry it off. Here's a closer look after I detached it. Here's where the relay was connected to the compressor, and here's the 3 pins on the compressor that plug into the relay. And here's another view of the relay from the opposite side. Now with the relay detached, you can measure the resistance between the different pins on the compressor, just to rule out the more rare case that the compressor is actually bad and replacing the relay wouldn't work in this case. Set your multimeter to ohms and then measure in between the different pins. If you get a little bit of resistance between 8 and maybe 20 ohms, then the compressor is fine. If you get absolutely 0 ohms, which means there's a short, then the compressor is damaged. But then again, this is a rarer case than the more common case that the relay is actually bad. It's so common, in fact, that you can order this part online. I ordered mine from Amazon, which came overnight for about $30. Not exactly cheap, but a lot cheaper than calling appliance repairman. And believe it or not, Amazon made the delivery at 7 a.m. the next day. So all I had to do was pick all of these 7 connectors one by one from the old relay and plugging them onto the same spots on the new relay. Now, since we're talking about live wires here, you can't make any mistakes. So in order to make sure I get this right, I made a schematic and shot a few photos of the old setting. Also note that these are wires from 3 different cables and the colors are not unique, so you need to write down the color of the wire and also the color of the cable that it comes with. Once that is done, and make sure to double check everything, all there is to do is plug the relay back onto those pins on the compressor. Make sure it's a snug fit because again the relay tries to measure the compressor's temperature by being attached to it. When everything is in place, it's time to put the enclosure back, let it snap in. Make sure that if there's water coming from above that is not touching the live wires. Fingers crossed. Let's plug it back in and see what happens. Now, at first, you might be worried because nothing at all happens. But let me tell you, it might take about 30 seconds for the compressor to get started. Then you'll hear this typical chirping noise. Looks like our repair was successful, pending a final test, of course. Put the water reservoir back in place, and yes, it feels a little weird, but it's just sitting loosely on top of the compressor. All done. Let's put the fridge back into its space and check the temperature inside. But be patient. It might take half an hour to an hour until the temperature inside the fridge drops significantly below room temperature again. And that was it. Hope this was helpful. See you next time.